We're going to be doing our yours truly word problem session now, and this is partially because Sam is not able to be here today. He's sick. We're missing Sam, the science guy, right now, but he usually does a science experiment on Wednesdays, and since he's not here, we're not really the science experiment experts. So we're going to do some word problems starring Nathan and me. So our producers, what has happened is our producers basically just created a bunch of word problems and starring us. They have to do with us, and they've been kind of poking fun of us in these word problems, which is kind of fun, and then have been challenging us to solve them. So am I supposed to pick the first one?
Yes.
All right, I'm going to pick the first one. So here's the first one. This one's called Nathan's Side Business.
Oh, interesting.
Here we go. So Nathan likes to entertain kids. He dresses as Darth Vader for birthday parties. As Darth Vader, he makes $7.50 per party. Wow, Nathan. Ooh.
Hey, it's not for the money. I just love to see the joy on the kids' faces.
So he attends 8 parties in June, 6 parties in July, and then some parties in August. He made a total of $202.50 during those 3 months. How many parties did he attend in August?
All right.
All right. Let's solve it.
I wonder how much I'm making hourly on that. About
very
$50
much.
an hour or so.
All right.
I mean, this just gave me a new idea. I might not be on the show anymore. I might just be Darth Vader.
New job.
Parties, yeah.
Yeah, this may not be a side business for that much longer.
Yeah, this might be a side business. All right. So I make $7.50 per party. Let's see. I wonder how.
So $7.50 per party. So let's write down our key information.
Let's write that down. Okay, so $7.50 per party.
Okay.
What else I got?
You're going to 8 parties in June.
So June. Oh, so I'm like fully booked up both days.
And you're
of the
doing
weekend.
2 parties a week.
I'm probably going to start bringing prices
No
up.
weekends for you.
Very in demand. All right. So June, I did 8 parties.
You did 6 in July. That must be the slow month.
It is. It's
Everybody's
a little
having
hot
pool parties.
Yeah.
Instead.
And honestly, I can't put on like gear and stand out in 90-degree weather.
It's so true.
I usually take some time off.
You may melt.
How many did I do? 6?
You did 6 parties in July. And then August, we don't know how many. Some. Just some.
Yeah, maybe I just want to make 200 and 250. How many parties do I need to do?
Good luck.
I think it's going to be a lot. A lot of parties in August.
So that's our unknown.
So we're going to throw I can throw a P in there for parties.
P for parties.
Yeah. I like to use variables that are easy to remember, especially if you get in the habit of doing this now. Then when you get to higher level math, like calculus or even advanced algebra, when you have multiple variables, it's much easier to use letters that are going to help you remember. So if I use X, I don't, like, what is X? But if I use P, maybe it's parties.
It's parties.
Obviously.
Duh. Okay, so then more information. He made a total of $202.50.
Totaling, wow.
Man, you are raking in.
Guess I don't need that $20 from you after all.
No.
Should be good now.
I'll take the $20,
Yeah.
thank you. This is coming from this fund, huh?
Yeah, if you want a side job booking parties for me.
Yeah, I'll help you get the parties. I'll get you more than this, don't worry.
Okay. So let's think about this for a second. I'm charging $7.50 per party. So if I only do 1 party, that's going to be $7.50. If I do 2 parties, that's going to be not times 15. Times 2, I'm going to be making $15. So if I did 3, I'd make $22.50 and so on. So really what we're doing to figure out how much I'm making per month is we're saying how many parties did I do and how much am I charging, and we multiply those together. So here's what we have. I'm going to calculate in June how much I made. So I did this, and I'm 8 parties times $7.50 per party. That is a solid $60. Then in July, I did 6 parties. It's still $7.50, and I made $45. And the question is, how many parties did I do in August.
I think you did a lot.
I did a lot of parties, that's what I'm thinking. So here's what we need to do. So I made $60 in, so let's think about this kind of like this. It's the amount I made in June, plus the amount I made in July, plus the amount I made in August, needs to add up to $202.50. So let's just plug in everything we know. So I know in June I made 60. I'm adding that to July, I made 45. So if you add those together, I made $105. Now for August, I don't know how many parties I did. I just did so many I lost track. So I'm gonna say $7.50 times whatever that number is, P. That's gonna be $202.50. So all I'm really doing here is, again, coming back to the algebra, is I'm trying to solve for P here. So I circled the 750 because we're multiplying that. So I'm going to work through this and simplify. 60 plus 45 is 105, plus that 750p equals 202.50. We subtract 105, and we get, what do we get? 97.50. And then we get 750p equals 97.50. So we divide the 7.5, divide the 7.5.
So you made $97.50 in August.
In August, so it's at like 13, yep.
Nice.
So these cancel out, and I did P equals 13.
13 parties.
Yeah, I'm gonna be honest, August is the end of summer, and I haven't been working because I'm a teacher, so I'm running out of money, and I just gotta crank out some parties so I can just pay my rent, really.
You should wear your Darth Vader costume on the show sometime.
Yeah.
That's what I'm thinking.
Give me $750, and I'd be willing to do that.
Nate, you picked the
All
name.
right. Let's grab this one because it's a different shade of purple.
Oh, okay.
Oh, it's me again.
Well, Becca dominated yesterday.
Yeah, I
Yeah.
did. So it's only fair.
Okay. So Nathan is a first-year teacher.
What's this one called, though?
Oh, sorry, Nathan's first year.
Nathan's first year.
So Nathan is a first-year teacher. 12 out of 16 teachers in a school staff meeting were first-year teachers. What percentage of the teachers in the meeting were first-year teachers?
Oh, okay. So 12 out of 16. So hang on to 12. First-year teachers. Okay. Wait, is this including you?
So with the way I'm reading it, it is not, or it is including me. I would think that, and that would be a kind of a tricky, ambiguous problem where it's not quite clear. But it says Nathan is a first-year teacher, and then it says 12 out of the 16 teachers were first-year teachers. So I would take that as 12, including Nathan.
Okay.
Typically, a math problem will be a little bit more clear because they don't want students to give ambiguous answers or to get different answers. But if I had a student say, put 13 out of 16, and then I told them they were wrong or asked them how they got that, and they said, well, I'm including Nathan, then I'd be totally happy with that because it just shows that they're thinking about that.
That they're critical thinkers.
Exactly.
So what
I'd
are we
go 12
figuring
out
out
of
again?
16.
Is it a percent?
Yeah, we want to know what percentage of
percentage?
teachers were first-year teachers.
Okay. Well, I've already started this a fraction. I said that there are going to be 12 out of 16 that are first-year teachers. They did give us the total already. A lot of times when we're asking percentage, we just really need to find a fraction first and then convert it to a percent. So we say 12 out of 16, and we want to turn that to percent. So a couple ways that I would do this. One thing I often talk about on the show, and I guess I haven't really talked about it lately, is just what this word percent means. If we kind of break it down, per means for every 100, or sorry, for each. Like if I just said, oh, well, you get three cookies per student. Here you go, 3 cookies per student. That means each, right? So, and that's exactly what I do every day, is I give 3 cookies to all my students. So, per means each, and then cent, if you think about that prefix, Nathan, how many years are there in a century?
100 years.
How many cents are there in a dollar?
100 cents.
How many legs does a centipede have?
Theoretically, 100.
Theoretically. I'm glad you said that. Yeah, theoretically. So 100, that prefix cent means 100. So if you think about percent, that means for every 100. So essentially, if I was finding the percentage, I would want to know if this proportion held true, 12, for every 12 out of 16, that if I had 100 teachers in that room, then how many of them would be first-year teachers? So one way to possibly do this is to find out, set up a proportion, and find out, I'm going to make an X here, how many out of 100 this would be to find my percentage, really, because percent means out of 100. So if I set up the proportion, I can, and you actually, part of why I did this is because you saw Nathan solve one of these earlier today. We are going to cross multiply, so I have 12 times 100 equals 16 times x, which then means over here I've got 1200 and then 16x. Then I'm going to divide both sides by 16, and what do I get, Nathan, Mr. Calculator?
16 divided by 1200, so 16 divided by 20 is what, 8? So 80?
Are you sure?
Pretty sure.
Nope.
Was that wrong?
Yep.
What is it?
You were close though. It's 75.
75.
And then we get that. So that means that 75%. This is not necessarily the easiest way to do it, but just breaking down that idea of percent is for every 100. It would mean that 75% of the teachers in that room are first-year teachers. Another quick way to do this would just be to do 12 divided by 16. That fraction bar really does mean division. And what would happen is you'd get 0.75. And then to turn that to a percent, what we do is we multiply by 100, which would also give you 75.
You could also,
least common denominator.
that's what I was going to say, you could have simplified.
And yes, that's so funny you
Reduced.
said that, because I was like, well, if I described it another way, I would do it this way. So we could simplify this if you wanted to think of this as like, I can divide these both by 4. That would give me 3/4, which is a very common fraction to know what percent is. There are some of them that you just should know. Like you should know 1/2 is equal to 50%.
Right.
You should memorize it. You should know that 1/4 is equal to 25%. It's just one that you use enough, you should just memorize. And 3/4 is one of those. So that's another way that you could do it. So there you have it.
Yeah, I actually, before we started doing this show, because I always taught high school math, before I taught like calculus and pre-calculus, I didn't realize how much we actually use ratios for, that
Everything.
I just don't really relate them. Like I always do percentages, but I do them a little bit differently. Like I would just do 12 divided by 16.
The division, yeah.
And then multiply by 100. But that cross multiplication, those ratios and proportions come up over and over and over again. So get very comfortable with them.
They do. Ratios are in almost everything.